we said we were going to give more examples of big O, so let's start with a simple one. And because it's simple, I'm going to ask you to think about this. So given this function, which given a list, it returns the first element. So what is the big O of this function? Well, okay, so hopefully it's obvious that because this function always only returns the first element in the given list, and it does that regardless of if the list has one element, 100, or a billion elements. It's only going to take the first one. So that's just constant time, regardless of the size of input. So that's O of 1. Now, generally speaking, if you look at a function and the function does not have any for loop, while loop, etc., or it doesn't have any recursive calls, or it doesn't call other functions that might, throw this whole calculation off, then it's a safe bet that the function is O of 1. So as you can kind of tell, all of 1 algorithms, they are really kind of nice because it doesn't matter how big your input space is. It always just takes the same amount of time, right? Whether it's 1 second or 1 minute, it doesn't. The exact amount of time, it doesn't matter. But what matters is it's constant amount of time that does not change. So sure, these are good algorithms, but when you think about it, okay, in the real world, are there really a whole lot of problems that can be solved in just constant amount of time? Well, and you might not think that there are actually many problems like that. Well, as a matter of fact, there is one very well-known example like that. Think about search engines. So for search engines, the input to the search engine like Google is the entire internet, right? And the internet, the size of the internet has grown since its inception many decades ago, and especially recently, right? And I put up a graph of how fast the internet has grown, and that this data is really, it's more than 10 years ago. So you can imagine the internet is a lot bigger now. However, so that's the size of the input to a search engine. Now, when you think about the output from a search engine like Google, it's the search result, right? How long does it take for Google to come up with a search result? Usually, it's pretty fast, right? Actually, I think most of the time it's very fast, except if the internet is down or something. My connection is down, right? So usually, Google actually very proudly display the time it takes them to search to find your result, and it's usually under a second, probably much under a second. So, and it has stayed that way over a long period of time. Whether it was 10 years ago, where the size of the internet is probably, I don't know, 1,000th of the current size, right? Or today. So actually, so you can kind of, if that's the case, then you can say Google search algorithm, or at least its implementation, is actually constant time, which is, when you think about it, that there are billions or maybe even trillions of web pages out there, and it's able to search through most of them in constant amount of time, under a second. It's crazy, incredibly good. Okay, so, and that's why companies like Google is worth billions and billions of dollars. So anyway, I thought it was just fun to point this out regarding constant time algorithms.